Hey there! We've just released a new space on Hugging Face to automatically scan any text classification model for robustness, performance, and ethical vulnerabilities. We recently ran an analysis of the 10 most downloaded text classification models on the Hugging Face hub and found loads of vulnerabilities. First off, 90% of the models lacked robustness, meaning they fail to resist minor changes in input data like typos or text case changes, leading to unreliable predictions. Second, over half of the models showed performance bias, which means they were performing poorly in specific data subsets despite having an overall decent performance. More than half of the sentiment analysis models displayed some kind of ethical bias. These models are downloaded and used every day, but they're full of performance, robustness, and ethical issues that are going under the radar. We're trying to change this, and that's why we've released a public space on Hugging Face Spaces to help with this. Let's jump into it. What this space does is that it scans any text classification model from the Hugging Face hub to find potential vulnerabilities. You can do this with your own model or an existing model from the hub that you may be using. So what I'm going to do is I'm going to go select the most downloaded model. You can directly copy the model ID and paste it in the space. It's then going to automatically detect the dataset that was used to train the model. Otherwise, you're going to have to go and copy paste that dataset ID over here. This is a sentiment analysis model, so I'm going to select the sentiment dataset config. And I will select the validation split. To make sure everything's working, we're just going to validate the model and dataset. Looks like we're good to go. We get an example input and the predictions. But it looks like everything's working fine. In case things look a bit strange, you could go into the label and feature mapping over here to confirm the pre-processing details and make changes to the label mapping. To make this run faster, we advise you to use the Hugging Face Inference API, and for that, we'll ask you to input your Hugging Face access token right here. This is a temporary token I've just generated. And finally, you have advanced configurations for the scanning, which is the function in Giskard that's going to be taking care of detecting all the different ethical, robustness, or performance issues. Once you're happy with the configuration, you can click on Get Evaluation Results, and it looks like the evaluation was successfully submitted. Now, it's going to tell you that you're going to be able to view the details of the job in the Logs tab. So it looks like everything's running, and we're back. So it looks like the job just finished. What I'm going to do is go into the model card in the community section. And as you'll see, there's a discussion that's just been opened by the Giskard bot. I'm going to open this. As you can see, there's a report that's been published based on the scan results. Report goes, "Hi team, this is a report from the Giskard bot scan. We've identified 8 potential vulnerabilities in your model based on an automated scan." It tells us on which subset and split the analysis has been done, and gives us a list of the different vulnerabilities that have been detected. For example, you'll find ethical issues, and as explained, when the feature was perturbed with a transformation which is switch religion, so this means when we switch the religion in the sentences, the model changes its predictions in 7% of the cases. In an ideal world, we would expect that the predictions would not be affected by this transformation. You'll always find a severity level, a metric, and a taxonomy. We are currently using the Avid ML taxonomy and some examples. You'll also notice that the same thing happened when you switched genders in the sentences, with the model changing its prediction in 5% of the cases. The scan also detected robustness issues when adding typos, transforming to uppercase, to title case, and removing punctuation, or transforming to lowercase. It looks like the model is not consistent in its predictions. Finally, we also have performance issues where subsets of the data look like they're performing lower than the global performance. And we've now come to the end of our report. If we go back to this space, you'll also notice that we have a leaderboard section in which we've logged all the different models that have been scanned by this space. You'll see a list of model IDs, dataset IDs, the total issues, and of course, a link to the report, which is what we've just seen. So as you've seen, even the most popular models are flawed, and detecting vulnerabilities is actually quite difficult. If left unchecked, they can lead to massive loss in performance on real data. What we're trying to do here is to answer questions like, is my model robust to perturbations that might be seen on real data? Was the training data diverse enough? Does it underperform on important data slices? I encourage you to give it a try yourself, and don't forget to subscribe to our channel to discover more demos on how to evaluate your LLMs and ML models. Thanks for watching.